Okay, so I added in a little more of things we've already seen. With the fireball, I thought, well, maybe it would make more sense if there was a dragon spitting the fireball, and then the human image, I just flip that horizontally so that it faces the dragon. So more of what we've seen, and now a human just appears somewhere randomly on the right half of the window. So we're ready for actually setting up a collision between the fireball and the human. And once again, this was just a quick test image. I think I spent 2 minutes on it. Obviously, if this game was going any further than just a test environment, probably want to spend a little time making a nice sprite sheet for that and make it look nice. But it'll work for testing. Just a quick drag an image and then flip the human character around and put it somewhere on the right half of the screen, which is all things we've seen before. Just load in a sprite, create some variables for the position, which are just at some random position on the right half of the screen, and then blit the sprite onto those coordinates. So now we're ready to check the collision. And to do that, we'll need a couple more parts. We need something about the image. We need to know the bounds of that image. And we can get that. We can get the rectangle information from that sprite we loaded in. So we can just use that for a quick one. So like fireball rect is going to be the fireball sprite, which is a PyGame object. So it has some stuff built into it. One of those being this get rect method. So that would give us the basically bounds of that sprite. And then we have XY coordinates of that we can mess with. And we'll need the same thing for the one it's going to collide with. So the human rect is the human sprite and dot get rect. And then that'll give us the bounds of those two images we need a collision to happen between. And we definitely want that rectangle to move with the image. So whenever we call those things, so here where we blit it on the screen, in this method we can go ahead and adjust the rectangle as well. So what do I call that? Fireball rect.x is going to be assigned this local x that we passed in. That way it's always at the same position as our fireball image. And then same thing for the y. So the fireball rect, the rectangle, also has a y coordinate that we can assign the same y value we assigned our fireball sprite. That way they're always together, and same thing for the human one. Human rect.x will be that local x, and human rect.y is going to be assigned to that local y. That way those always stay together. And then down here where instead of just drawing it, we want to check and see if there's a collision before we just draw it. And once again, we can use things built into the PyGame engine to set that up. So in an if statement, we'll look at that fireball rect object, and it has a built-in method called collide rect. All lowercase letters, so collide and then rect. And I have a tendency to put two R's there, so be careful with that. There's only one R. And then we want to check what we are colliding with. We want to know if we collided with that human rect. So if there's any intersection between it. And if there is, I guess we'll to test move to different place, increment a score, we'll come back and put a score. Otherwise, we will just draw the human X where it is. Oh, and then I guess we'll need to draw the human at the spot it was at if we don't actually go up at the new spot. And to set up a new spot, it's just going to be the same random values we set up here. So just a random number between 0 and 300 plus 400 to move it to the right side of the window, and a random number times 400 plus 10 to choose some up and down position. So if there's a collision, we'll just move to that different spot, and we'll come back and do the score after we give this a test. So save that, scroll up and run this, and I'll pause the video while it loads. Okay, almost as expected, I got a typo while talking, but quickly fixed that, and the logic was all correct. So we can spit fireballs, and they'll go right past our character. Hopefully this one will collide with our character. Yep, and it moves someplace different. Oh, and I guess at that point we could destroy the fireball too. So go across, boom. And that's setting up our collision. Once I got the typo corrected, I left an E out of fireball somewhere. And it's still taking forever to load, so there's no need to watch that loading. But whenever that collision happens, we should probably move the fireball X off the screen. Fireball X equals 768, right at the edge of the screen. That way it is just ready to kick in this other condition that resets our fireball. So once the collision happens, kind of get the fireball out of the view, put the human someplace else, and now we're ready to put a score variable in here, which is a fairly straightforward thing to track. Obviously, to track the score, all we need is a variable to do that. I'll come up here and set it up right under the initializations. So the score is going to start at 0. And then to write it, we'll need to write it on the screen as well, show it somewhere. So a quick way to do that is we can just initialize a PyGame font object. PyGame font dot initialize, and well, we'll initialize that library, and then we'll create a PyGame font object to write the score with. So our score font will be PyGame dot font dot system font, and you probably may have noticed the PyGame is very inconsistent about how they spell it. So this one's all back to Pascal case for the system fonts. And one I know I have on here is Times New Roman. Could go check and look through and find a good one, but I know the computer has Times New Roman. I'll make it 22 pixels tall. So just font.initialize, and then font.systemFont to save the type of font object that we can write with. So the next step should be obvious. Here where that collision happens, we'll just increment the score by 1. So if there's a collision, our score variable, increment assignment by 1, and then after we draw everything on the screen, I always like to put well, it's not much of a HUD, but showing the score, I guess, technically fits the definition of a HUD. I always like to do that above all of the other objects. That way it definitely shows on top of anything. So I'll just make something up here, show score. Well, that'll be that score font we created, and then the dot render method for it. And this takes in three arguments. So first off, what string is going to show? So I'll put score plus a string that score integer. Cast that score integer into a string. So that's the words we want to put up there. The second one is false. It's a true false thing. I can't recall what that stands for. I haven't used that it's been so long since I looked that up. I just always type false. I never use that one. It starts with auto. Maybe I should look that up real quick while I'm doing the video. So I pulled up the documentation, and that second one is anti-aliasing, which I never use, so I always just pass in false. And then might as well point at this while the documentation's up. Then we need a color and where we're going to put it. So for a color, we can pass in an RGB value as a tuple. So I'll just do something dark, maybe not quite black, not all zeros, but still gray. So like 12, 12, 12 is a tuple, and get a color. So the words that we want to show, false or true or false for anti-aliasing. Well, a tuple of numbers or false for anti-aliasing, and then a RGB color as a tuple. So I'll just do 12, 12, 12. And once we have that, then we can go ahead and call the blit method to put that on our screen. So screen.blit, show score, and we want that to be at I don't know, 30, 30. Probably seems like a good place. Let's give this a run and see if that works. So once we create our score variable and font object, then it kind of follows the same pattern. We'll create an instance of the show of the font with the .render method and pass in the words we want to show, anti-aliasing, and then the color it's going to show in, and then just call blit for where it's going to show at. I call the blit method and pass in the coordinates where it's going to show. So I'm going to pause. There's no need to watch this load in. Okay, apparently that time I was able to type it without making any typos. So the character moves around. You see our score up here. And I'll spit a fireball to miss first. Didn't do anything. But if I throw a fireball and hit the character, oh, you see the score went up by 1. So just kind of the basic idea of a game there. So that's probably enough for this test. And yeah, all the other buttons worked as well. So I guess next up is going to be a 3D test with this controller. And obviously, if this was going to go anywhere beyond this test, spending time on animations would make a big difference on this. But it all seems to be working and kind of fills the purpose of testing the controller here.